Welcome to this section on testing your serverless microservice. In the previous section, we created a fully functional serverless data API using API Gateway, Lambda, and DynamoDB. The testing I showed you was in the AWS console, which is okay for small amounts of simple development code, but not recommended for production systems. It's much more efficient for a developer to actually write their code locally and then test it. And it's also essential for continuous delivery systems to be automated. They need these tests to be widely available. So this section is all about testing. Testing could easily cover a whole course, but in this section we will keep it very practical and focused around testing your serverless code and data API. In this section we are going to talk about unit testing your Python Lambda code first. Then we are going to discuss running and debugging your AWS Lambda code locally. Then we will discuss how we can run integration testing using a deployed Lambda and real test data. And finally, we're going to discuss how we can do performance or load testing of the API at scale and end-to-end. Welcome to this video on unit testing your Python Lambda code. In this video, we're going to look at why testing is important, the actual sample data we can use for testing, unit testing, and mocking. So why is testing important? If you think about the collaboration and teamwork in large teams of developers, they usually have a distributed team, for example, in different countries, and they want to collaborate on the same source code or same repository. Then it's very important for them to actually understand the code and be able to test it locally to see how it works and also understand if it's still working as they expect or as the original developer expects. Another important point for why testing is important is the quality. By having lots of tests, you can actually identify defects early. And for example, you could decide not to release the code if there are major bugs. Another point is usability. For example, the client might have performance requirements. You could imagine an e-commerce website, for example, where you would add items and you would have to wait 1 minute for that to be added to the basket. In most cases, that would be unacceptable. So the idea would be you would have some sort of testing process to make sure that the latency is still low and the website is responsive. The last point I think that is important is having shorter release cycles. This is where using automation, you could run, for example, 1,000 tests automatically without having a human to actually test different parts of the site manually or test the APIs manually, for example, or have any rigorous code inspection. So after you run those thousands of tests before every release into production, you'll be really confident that everything is working and is in correct order. So now I'm going to show you some of the sample code. So again, I'm using the PyDev. So first we're going to look at the sample dataset. So if you open the project, the first request API Gateway valid no date actually contains the filter, which is just the user ID. So there's no date filter at all. And this essentially is all the payload regarding the API request that will be required for API Gateway. The other example I've created is one which has the date filter already. So you can see there's a query string parameter with a start date. And any data for the specific user 324, we want to only retrieve data after 2017 of October 14th. So nothing older than that. That's the idea of having this query string parameter which we used earlier in the course. I also have others which have, for example, no user. So this user does not exist within the DynamoDB table. And the other example I want to show you is that we have an error where the actual valid user IDs are numbers. And here we have an F which makes it invalid. So we want to test that. So the other file we had was the one that we loaded into DynamoDB, which looks like this. We have an event ID, an event day, and an event count. So if you open the test folder, and if you look at this Python file, you'll see that I've created tests. So this is a test suite using a test class where we've got a setup. Essentially, I'm setting up some basic payloads for the Lambda and API gateway. So the first one, I have a resource 324, and it's correct. I'm also passing in a start date as a parameter, query string parameter. The invalid JSON data is actually just invalid JSON. You can see that there's no key pairs or double quotes within there, so that's totally invalid. The last example I have is no user. So this is a user that does not exist within the DynamoDB store. Teardown is usually, this is the setup, which is at the start, and teardown is at the end. So the first function for unit testing I want to show you is this one. Essentially what we're doing here is we're passing in the valid test data, and we're checking that this start date is the correct start date that we're expecting, and also the resource ID, which is the user ID, is 324. And this assert statement allows you to validate if that is true as a statement. If you want to run a unit test within this environment, you can right click and do debug as Python unit test. And you will see that one test ran and it was okay, which means that test has actually passed. The next one I want to show you is an invalid JSON payload. So if you remember, we have the test invalid payload, which is these invalid JSON. So there's no way that any system that passes JSON will be able to pass this. So here we're checking if the status code is 404, and also if we're checking if it's not found. So you can right click in the same way and run it as a unit test. You can see that there's an exception. However, this is expected behavior since the JSON is actually invalid itself. But you can see at the bottom that one test ran and it's okay. Again, you can't do anything with invalid requests. So it's a good practice to actually have defensive coding in these scenarios. This is where this will not bring down your API or cause an unexpected exception. Here we know that the request is invalid, so we are letting them know. So the next one I want to talk about and show you is the mocking framework. So what is mocking? Mocking basically allows you to replace parts of your system under the test using mock objects, and then you can run assertion statements on those. So here we are mocking one specific method, which is query by partition and sort key. And essentially you can see that if we run this test, we want to make sure that we get a 200 code, which means that it's valid response. We can either right click, run as unit test, and you can see that the test ran okay. So we're confident that by effectively mocking DynamoDB, we get the data back. Here I have another one, which is the same as above, except that we are adding the filters by event day and by sort key. And we can run that in a similar fashion, run as unit test. And you can see that that also passed okay. So you can see how you can build up a chain of different tests, different scenarios. I've tested, for example, different exception cases. And this is really important to make sure that the code is robust. So if you can imagine, if you're not using an IDE, or if you want to automate tests, what you would do is actually go to your code, and the system that's doing the automation could run something like this. You can see again that the 4 tests have ran okay, so you can be confident that everything is working.